He's a experienced product manager or product person and an entrepreneur with 12 years of experience in ed tech, enterprise, SaaS, mobile, and data, and working with companies like Reddit and RightStop and Jano. He's a Stanford grad and an IIT Kanpur graduate, and built a product called Super Profs and has 1.5 million users monthly, and has been awarded the MIT Review Innovators Under 35 Award, which is pretty nice. And let's see, last thing is he's working on a new product called ProductMonk, which is a platform for product managers to learn. So I welcome Piyush to present for us. I'm going to remove spotlight.
Awesome. Thanks a lot for the kind introduction, Steve. Good morning, everyone. I'm super excited to be here and to talk about structured problem solving for product managers. Just a quick check. Am I audible clearly? If anybody could confirm.
You sound great.
Okay, awesome. Great. So starting with today's presentation, as most of you would agree on, the skills required by product managers vary quite a lot as you look at different types of organizations, as you look at companies at different stages, companies across industries and across business models. However, one skill which stands out universally, which is also a significant contributor to one's success as a product manager, is problem solving. And I believe that at their core, product managers are essentially problem solvers. Now, I know that this may sound like a cliche and something that you may have already heard multiple times. So let me first clarify what I mean by problem solving in this context. Oftentimes, when we hear the term problem solving, we tend to think about some kind of an issue or a bug in our product leading to a problem. Now, while identifying and systematically resolving such issues is an essential part of a product manager's job, I believe a much larger part is also to be able to identify opportunities for the product which lead to positive business outcomes. So in that sense, problem solving is not limited to, say, preventing negative outcomes like, say, reducing churn of your product, but is also equally applicable for achieving positive outcomes like, say, growing revenues for your product. Essentially, anything that you're trying to achieve is your problem statement, and problem solving helps you in figuring out how to reach your goals. So let's try to figure out, given a particular problem statement, how do we go about solving it in a systematic manner? Now, usually there are three, just give me a second. Usually there are, three types of problem solving approaches which people tend to take. The first one is to solve it from experience. And this is the most intuitive thing to do, and people are generally comfortable with this. Now, let me give an example. Let's say you are working in a bakery, and in the past, you have also worked in another bakery. And your current problem statement is to increase the revenue for this bakery. Now, from your previous job, you might have realized that red velvet cupcakes were all rage. So you decide to introduce red velvet cupcakes as a way to increase revenue for your current employer as well. Now, this is an example of problem solving from experience. Note that experience doesn't need to be your own. It can be the collective experience of the ecosystem. For example, let's say if you're starting a new company and you need email addresses with your company's domain name, you might just go and sign up for Google Workspace because maybe every other startup that you know of has done that, and you may not even evaluate the alternatives. Now, collective experience is what leads to best practices and default choices in a field of work. So if I have to work on data science, I would probably choose Python as my programming language because maybe it is well known that Python is most suited for that. You can, of course, go by the experience of your colleagues, boss, mentors, and others. So that is problem solving by experience. The second approach is what would be called as creative problem solving. Now, creativity by definition means that there isn't a very well-defined process of arriving at the solution. And even if there is a process, it is your individual one, not necessarily generalizable. Creative solutions are generally outcomes of an aha moment. Some people are more creative than others and can think of solutions that others may not be able to think of. Some people are very good at making out of the box connections. Now, creativity is a great thing, and when it works, it can do wonders. In the first bakery example, the introduction of the red velvet cupcake originally might have been the result of the owner's aha moment. But when it comes to problem solving in professional life, while both experience and creativity can help, they are usually not sufficient. And that's because of multiple reasons. Number one, experience may not always translate well. Red velvet cupcakes may not work as well for the second bakery as they work for the first one, because maybe the clientele is different. Perhaps the first one has already created a cult following with its red velvet cupcakes and buyers aren't too keen on another bakery selling it. Then you might be facing a novel problem which you have no experience of, or where even collective experience of the ecosystem doesn't show you a path or is not accessible to you. As far as creativity is concerned, it may not strike you when you need to solve a problem. And finally, even if experience or creativity provides you a solution, it is not guaranteed that you are not missing out on something more or better. And that is why we need a third approach of problem solving, which is what I refer to as structured problem solving. And that is going to be the focus for the rest of this discussion. Structured problem solving typically involves three key steps. The first one is framing the problem statement in such a way that the outcome is clear. Simply, it should be clear that you should be able to know whether you have actually succeeded in solving the problem and to what extent by looking at the problem statement. The second step is to break down the problem into smaller problems with the objective of identifying the most important opportunities to focus on. This is also called as breaking down the problem. And finally, the last step is to solve the smallest chunk of the problem or the identified opportunities. At this particular step, experience and creativity can also really help you a lot. Now, I know that this may seem either abstract or naive right now, but let's take an example to understand this better. Let's take the problem statement of improving activation for an e-commerce app. Now, before talking about applying structured problem solving for this particular problem, let's think of how most people would have approached solving this problem by experience or with creativity. For example, I found that it is not uncommon for people to jump to the conclusion that by giving a discount code or a promotion code to new users, you can actually improve the activation rates of your app, because maybe that's what you have seen happening with most other companies and most other applications. So that's an example of problem solving by experience. Now, some creative people in the room may come up with the idea that by revamping the user interface of the application, we might see better activation rates, as users will find it easier to navigate the app and it will also look modern. Now, that's an example of problem solving with creativity. These are just two examples of how different people may approach the same problem. But the point I'm trying to make here is that none of these proposed solutions to the problem are guaranteed to work. And if implemented in their current form without any further validation, they may consume bandwidth and resources of your team without actually solving the problem. So let's see how structured problem solving can be applied to this problem. As we discussed, the first step in structured problem solving is to frame the problem. The outcome of this step should be a very specific and clear understanding of what problem are we solving. In other words, problem statement should be framed so that outcome is 100% clear. Using this framed statement, it should be easy for you to answer whether you have succeeded or failed in solving this problem and to what extent. Now, framing the problem itself can be divided into three sub-steps. The first step is to define the concepts. For example, for the hypothetical problem of improving activation rates for the e-commerce app, we first need to define clearly the term activation. So let's say we define activation as percentage of users acquired who place an order within the first 24 hours of acquisition. Now, you might notice that this definition introduces another term, which is acquisition, which needs to be defined properly. We could define acquisition as, say, signing up on the application. Now, this is important to define because if instead of signing up, we define acquisition as the installation of the app, then the scope of the overall problem will change quite a lot. For the purpose of this example, either of those definitions will work. So let me just pick up signing up on the app as the definition of acquisition. So with these terms identified, we can define activation rate as the percentage of users signing up on the app who place an order within the first 24 hours. The next step in framing the problem is to establish a baseline. Now, in this case, the baseline could essentially be your current activation rate. For example, let's say based on a simple funnel analysis, you find out that out of every 100 signups on the app, 40 of them place an order within 24 hours of the signup. This is, of course, an hypothetical example. In this case, your baseline activation rate is 40%. Finally, after defining the concepts and the baseline, we go to the final step of framing the problem, which is to set the target. In this case, this particular metric needs to move up. You could consider anything above 40% to be an outcome, or it will be even better if you had a specific goal of, say, taking the activation rate from 40 to 45%. So here is how your improve activation problem statement looks like when properly framed. It is taking the activation rate from 40% to 45%, where activation rate is the percentage of users placing an order within 24 hours of signing up. Now you can see that with the problem statement clearly defined like this or framed like this, you would actually know if you really succeeded or not in achieving your outcomes. As a recap, framing the problem is the first step in structured problem solving. The next step is to break down the problem, which is what we'll discuss next. But before we see how to break down a problem, let's understand that the expected outcome of this step is to determine the smallest chunks of solvable problems, also referred to as opportunities. So let's continue with our example of improving activation rate in the e-commerce app that we discussed in the last section. Now, to break down this problem, we need to look at what happens between a user getting acquired and it getting activated. Let's look at the user journey from acquisition to activation. Let's say for this hypothetical e-commerce app, after signing up, users come to some sort of a landing page or a landing screen or dashboard from where they search for or browse for products that they are interested in, and then select one or more products and then place the order. Now we can break this down by drawing a funnel and seeing where most people are dropping off the most. The corresponding funnel can look like the one shown on your screen, where we have funnel steps like, say, viewing the landing screen, viewing a product screen, adding a product to cart, and others. For every step of the funnel, you also need to have the number of users who reached that particular step. For example, as per the hypothetical data shown on your screen, 100 people visited the landing screen, out of which 90 visited one of the product screens, 60 out of those added a product to cart, so on and so forth. You get the point. So once you have a funnel like this, you would want to see where the maximum drop-offs are happening, because that is where the maximum improvement opportunity may lie. But breakdown is usually not a one-step process. Oftentimes, you would want to break down the steps where the maximum drop-offs are happening multiple times or even further. Let's change this example a little for further discussion and say that the funnel actually looks like this, where there is a lot of drop-off happening at the second last stage, which is the making payment stage. You can see that 20 out of the original 100 people are dropping off after they enter their address and before making the payment. So you can break down this step further to see exactly what is happening. While trying to break down this step further, a logical question to ask might be, what are the users supposed to do on the app after they enter their address and before they make a successful payment? If there are multiple steps between these two stages, you can draw a deeper mini funnel between these two steps. For example, let's say there can be a sub funnel with 3 steps, which is number 1, selecting a payment method. Number 2, entering the payment information or card details. Step 3, completing the transaction. Let's say this was a sub funnel that you created. So once you have a sub funnel like that, you might ask, are there drop-offs happening at the time of payment method selection itself, or majority of the users selecting a payment method but not entering the payment information? Or are they selecting the payment entering the payment information, but they are trying to initiate the payment, but then they are getting an error? Now, some of these sub-steps can further be, if you're seeing significant drop-offs, can be broken down into further sub-steps. For example, if people are trying to make payments in the last stage and are getting errors, then you would want to break those errors by the selected payment types or selected payment methods. For example, you might observe that credit card payments, for some reason, are having a higher error rate compared to other payment methods. In that case, a follow-up question would be if there are specific banks' credit cards which are seeing the errors. In this example, like these are all hypothetical examples, but you might identify the smallest chunks of the problems to be, let's say, these three, which are shown on your screen. Maybe the method of payment, which is popular amongst the users, has a high failure rate. Or maybe you are selling high ticket size items and most people prefer paying for such items in installments, but the option to pay in installments is hidden or difficult to find in your user interface. And so most users are not discovering that. Or perhaps people are entering their credit card information, but they're getting confused in doing that because maybe your credit card details form is different from what they typically encounter on other apps or sites. So these are examples of breaking down the problem to find the smallest chunk of problems or opportunities. Usually, there are three broad ways of doing a problem breakdown: funnel breakdown, category breakdown, and component breakdown. We have already seen an example of funnel breakdown in the e-commerce app that we just discussed, so I'll not repeat that again. Instead, let's look at an example of problem breakdown by category. Suppose you run an apparel store, an offline one maybe, where the problem statement is to increase the revenue. Let's assume that you have already properly framed the problem and you know the current and target revenue, so you can focus on the breakdown. Now, category breakdown here can literally be a breakdown by product categories. For example, the revenue from your store can be broken down into revenue from, say, women's wear, men's wear, kids wear, or accessories. Further, revenue from women's wear can be further broken down into, say, ethnic wear, western wear, and so on and so forth. Basically, each category stands by itself. When you do a breakdown like this, for the solutions, you would try to figure out how to increase revenue for one or multiple particular categories. Now let's move on and understand the last type of breakdown, which is component breakdown. Continuing with our example of the apparel store trying to grow its revenue, if you do a component breakdown of revenue from the apparel store, it would be something like this, where revenue is equal to number of units sold multiplied by the average price per unit. When you break down the revenue like this, while coming up with the solution ideas, you would want to figure out how you can increase the number of units sold or the average price of each unit or both. So those are the three kinds of problem breakdowns. I'll pause here for maybe a few seconds for this to sink in. So moving on, in real life, while solving a problem, as you have seen, we typically need to break it down multiple times. And we would usually end up combining different kinds of breakdowns for the same problem. One way of combining the breakdowns you will definitely use is hierarchical breakdown. So in case of the apparel store, I would perhaps do multiple levels of category breakdown to reach the smallest actionable category. And then to figure out the solution for that category, I would do a component breakdown by the number of units sold for that category and the average price of the units sold for that category. So as you would agree, it is definitely much more tractable to think of how to increase the average price of a particular category, let's say women's formal shirts, than to think of how to increase the price of all the items across the store. Same is the case for increasing the number of units sold. In addition to hierarchical breakdowns, sometimes it is also useful to do different kinds of breakdowns at the same level and gather relevant insights. So that concludes the section on problem breakdown. As I mentioned earlier, the expected outcome of the problem breakdown process are opportunities or smallest chunks of the solvable problems. So with that, we have covered the problem space in structured problem solving. And since we have spent so much of time in this by framing the problem and breaking it down to the smallest solvable chunk, we need to spend much lesser time in worrying about the solution space. That's the beauty of it. Now on to the third and final step of structured problem solving, which is actually solving the problem. When you have broken down the problem and have identified opportunities at the smallest level, then many a times the solution is quite logical. For example, if you realize that after working on the problem space that the users want to pay in installments, the logical solution would be to move the corresponding payment option or payment method up in the list, at least for high ticket size items. Similarly, if let's say you figure out that if a particular payment method has a high failure rate, then finding the reason and fixing that is a logical solution. At this level, coming up with solutions from experience or creativity are also perfect ways of solving the problem. However, note that it is after breaking down the problem that you should take the advantage of experience and creativity. Here are some examples of solving the smallest chunk of the problem from, say, experience. Say we have identified that the particular payment option has high error rates. Maybe you have seen in your previous company that the payment option gives higher error rate with our current payment gateway provider. A different payment gateway provider works better for the payment method. So maybe the solution could be just to integrate with a different payment gateway provider. Another example, perhaps you're running a coffee shop and you're using structured problem solving, and you have identified that the main problem is that customers are not walking into the coffee shop. You have seen that those who do walk in are happy and they generally tend to come back. From your experience, you know that spraying coffee sent around the coffee shop tends to attract customers. So maybe you should do that. To be honest, I can't think of solutioning examples using creativity right now. And that is the nature of creativity. It may not strike you when you need it. Right now, payments is so done to the death that most solutions around payment problems may come from mere experience. But maybe at some point of time, installment-based payments would have been a creative solution in a market where people were not comfortable in purchasing high-ticket sized items online. So that was the third and the final step of structured problem solving. So that brings us to the conclusion of this session. Let me do a quick recap of what we covered today before we open up for questions. Number one, structured problem solving is needed because experience and creativity may not always give you a solution. And even if they give you a solution, it may not be the best solution. Second, the 3 steps of structured problem solving are 1, framing the problem, 2, breaking it down, and 3, solving the smallest chunks of the problem. Number 3, the 3 steps of framing the problem are defining concepts, establishing baseline, and setting the target. Fourth, the 3 types of problem breakdown are funnel breakdown, category breakdown, and component breakdown. And finally, once you have the smallest chunks of the problem identified, you can solve them either logically, from experience, or creativity. All of them are okay. That's all what I wanted to talk about on the topic of structured problem solving for product managers. I'm happy to now try and answer any questions that you might have.
Okay, good. Great presentation. Thank you. So I don't see any, the session was good. I don't see any questions. I certainly have questions in terms of, the iterative process of this. So it seems to me that when you're first starting out, you're going to start this process and it's only going to lead you to more questions. So then, there's as the data exposes itself, you end up saying, well, maybe I did it wrong. Maybe I framed it wrong. How do I go back and redo all these steps again and frame it differently?
That's actually correct, Steve. And I would say that the gist of this process is to spend a lot more time on the problem space. And I think, honestly, it is completely okay that you take one route, let's say one type of a breakdown, and, go for this a few steps down the line and you realize that maybe you're not going anywhere, because that is the point of doing this, right? Because you are trying to figure out what is the actual problem and how solving that problem might impact your overall, outcome actually, right? So it's completely okay to take step back multiple times. In fact, that is what happens most times. And in fact, another thing might be that there's no single formula of exactly which type of breakdown to take, right? Should we try with funnel breakdown, component, or category? I think you have to try multiple things. And what I've seen in most cases is that as you keep doing similar exercises, it becomes more intuitive for you. So looking at a problem, you might become better at identifying the routes to take, but it's completely okay to take the wrong route and come back. I think it's far more efficient that way compared to making an assumption and jumping to the solution space and straight away implementing something.
Yes, great. I guess we got one in the chat that basically says, how do you see testing or customer interviews informing the solution?
Absolutely. I think that's a great point, Andy. And I would say that, one thing which I couldn't cover in today's discussion because of the limited time that we have is like, once you do have these breakdowns and once you've identified some of these small chunks or opportunities, how do you go to the third step, right? I mean, how do you pick the ones to really focus on? And that is where I would say a lot of customer interviews, and I would say, maybe some experiments or some data helps, because ultimately you might come up with 5 different problems which potentially you can solve, as part of this process, but potentially you can't do all of them, right? So that's where you put in your data, you put in your customer interviews or qualitative and quantitative insights, and decide which one you want to focus on. Similarly, testing and customer interviews also help you with the first step, which is breaking down the problem, right? For example, let's say if you're trying to break it down using a funnel, right, you might actually talk to customers to see what steps are they taking actually, right? So I would say customer interviews or data or testing are helpful across the entire process.
Okay.
I think Mike has a question. Typically, how do we allocate time between each step? I would say, Mike, I don't think there is a universal formula or like a ballpark figure there, like which we could do. Like in general, I would say I'm biased, but I think that spending relatively more time on the first 2 steps, which is framing the problem and breaking it down, is more important compared to the solving the problem. While ultimately the goal is to solve the problem, I do think that if you spend more time on the first 2 stages, usually you tend to get better results. Actually, that's what has worked best for me.